Yes. Mm. Mm. Yes. You have described you and you've described why. Mm. Yeah. Mm. For the first part, yes. Mm. So this is what you have to do. So y equals to x squared plus 4 power 10 plus x power 3 plus x power 2 power 9, okay? So I said yesterday that this problem, once we have done several problems on chain rule, so you should be able now to master the concept and do the problem applied to more than one part of the equation or the function. So for example, in this case, we see there are two parts. Like if you say this part A, this part B, okay? So the derivative of dy dx in this part A, your u function will be what? So x squared plus 4 will be the u, okay? So which means du dx is 2x, okay? Then when you lay that one, so it's like now we have y. If you just consider the part A alone, okay? So it's like we have y is the same as u power 10, okay? So when you say dy du, u power, correct, okay? Yeah, so by definition, chain rule says dy dx is given by, so dy du, correct. So that's by definition, okay? So our dy du is 10 u power 9, okay? So we write here as 10. Then remember u is the same as x squared plus 4, okay? And then you raise to power 9 because there we have dy du, this part, okay? Then you multiply by our du dx, we have gotten the answer to be 2x, okay? So that is the first part. Then I will simplify it further. Let's go to part B. Part B, u will be, mm, So that is du dr. So you have already defined dy dx. So 3x power 2 plus x, okay? And then so du, dy, du. So it's like now this is u power 9, okay? So 9 u power, yeah. As unaona unaelewa kila kitu. So then what simply means that then now the answer to this part is 9, but we remember that u is x cubed plus x squared, okay? And then you put 8 here, which is the power of u, okay? Are we together? And then you multiply by du dx, which is 3x squared plus x, 2x. So then now you can simplify further and say dy dx. So this 10 you multiply by 2x, you get 20x, okay? And then power 9. Then this 9 you multiply by this term, which this bracket, which is not which doesn't have a power. So 9 times 3x squared is 3x squared. 27x squared, okay? Plus 9 times 2x, 18x. And then you just multiply by x cubed plus x squared power 8, okay? And then that's the final answer. So that is how we're supposed to work on that problem. Yes. Yes. Mm. No, that one you don't have to open. It's in the simplest form. You don't have to. That's really not what the question is testing on. So this means that you have to multiply this bracket x power 3 plus x power 2. You don't have to do that. That's not the objective of the question. The objective of the question is just to ask you whether you understand how to carry out chain rule for more than 2 terms in a function. So if you have to open this one, then it means that you have to multiply this bracket by itself 8 times, which actually is not being. Yeah. Oh, that's a good question. When we have a very high powers, then you don't open the brackets. When you have this power, like say power 4, power 5, power 6, etc., you leave them the way they are. But small numbers like power 2, power 3, sometimes you can expand. But generally, when we have more power, higher powers, you don't have to open. You don't have to open. Yeah. Then we go to the second part. Yeah. So the second part was why. Do you have the question? So y equals to 1 minus x squared power 5. No, 3x. That one we done yesterday. Y equals to 3x minus 5 power 4 into 7 minus x power 10. Okay. So this problem, you should see that there's a product of 2 functions from the start. Yeah, like this, like u and this like v. Or maybe you told me your teacher was using f of x and g of x. Eh? Yeah, so let me stick to the notation of your teacher so that I don't confuse you. So this is f function, and then this is the g function. Okay. So which means then now when you have product of f and g, then we use product rule. Okay. Yeah. So you say dy dx is given by f prime of x times g of x plus g prime of x times f of x. Good. Okay. So then the question will be, how do we define f prime of x? Okay. So which rule do we use? So remember, f prime is f alone is. Let me just rewrite the function first. F alone is given by 3x minus 5 power 4. Okay. And then g of x is minus x 10. Okay. Yeah. So this means that f prime of x is given by. So how do you define the derivative of f of x? Mm. Mm. 4 into 3x minus 5. Then power reduces by 1 to get. And then you differentiate inside. Oh, well, we shall part jibu already. Okay. So, okay, sorry, you are ahead. So the thing is that now inside, when I wanted you to tell me the inside function before you do the final expansion, so you have already the last step. So when you differentiate inside, you get 3. Yeah, you had already seen the 12. The thing is that you use power rule to differentiate the way you have dropped 4, and then you reduce the power by 1, and then you differentiate inside again, then you multiply. But that's really similar what you have been doing. Yeah. So which will be 12 3x minus 5 power 3. Okay. Now you see the more you do this thing several times, the more you see what is happening. So maybe let me just take you back to the previous question to see what the same thing that what you are getting here will have done the same thing. So you saw in this problem, in this previous problem here, we would have actually done the same thing you're saying. That the first thing we drop the 10, okay? And then we have x squared plus 4. Then power reduces by 1. So you get 9 here, okay? And then una differentiate what is inside by unit 2x. So it's exactly the same thing. Sasa hii ingine utasema plus power rule na drop power, okay? So unakuwa na 9x cubed plus x squared. So new power of this bracket will be we dropped 9. So power itakuwa gani? 8. You also just reduce by 1, okay? And then you multiply by what do you get when you differentiate inside? Mm. Mm. Yeah. Then ndio vitu tulikuwa tunapata hapo. It's exactly the same thing. So that's really what is happening, okay? Yeah. So the more you do many questions, the more now you get the trick. Mm. Yes. Yes. Mm. 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 Yes, yes. Mm. 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 Oh, yes, yes, yeah. Yeah, yeah. So the thing is that now what I was doing, I was dealing with the way you have explained the other one. I was dealing with the ones I've already known that the bracket, this is what is going to be my u. Okay. So it's like I'm dealing with y equals to u power 10. So I can differentiate by power rule and drop 10, and then I reduce 1 from 10. Okay. And then sasa na differentiate du dx. Sasa ndio inanipatia u tx ndani hiyo. Differentiate what is inside. Okay, good. So let's get the g prime. So g prime 10 into brackets minus x power 9, and then okay, differentiate inside. Mm. Mm. Ukidifferentiate 7 unapata tena 7. Aya, kuacha ngapi? Hmm? No, no, there's nothing like opening brackets. I'm differentiating what is inside the brackets. That is what will give us du dx. Mm. Mm. Is what differentiating what is inside the brackets. Remember, this is what you are doing. The first thing that we are, but when you said 10 into x7 minus x power 9, you have already gotten, that's the same thing as saying the dy du. Okay. This part here, this answer you are giving here is what defines our dy du in the usual sense for the chain rule. Then we need to multiply by du dx. I remember you need e bracket, what is inside here? So what is the, if y is 7 minus x, what is dy dx? If you are given that function, differentiate. When you differentiate y equals to 7 minus x, what do you get? No, there's nothing to take to the other side. The problem is very direct and is the way it is. So when you differentiate 7, what do you get? When you differentiate 7, what do you get? Mm. Sure. That one, you'll be allowed to say 7 just for today, but now from this class, if you say 7 now, you are going to Derivative of 7 is what? I remember you are the one who proved, you are the one who told me that derivative of f of x equals to 20 is 0. And 20 is a constant. So when you differentiate a constant, you always get 0. Note that. Derivative of a constant is always 0. So when I ask you to find derivative of 7, I don't expect you to struggle. You should just, the answer is 0 because it's a constant. So derivative of a constant is always 0. So then now dy dx of 7 is just 0. Now when you differentiate negative x, nakupatia ngapi? Oh, no. Can't be 0. Angalia. This is negative x. It's like I have power 1. So when you use the power rule, what do you, how does the answer look like? Just power rule for differentiation. And then, so x power 0. So then the answer is -1, okay? So then now when you differentiate inside, you get -1. So you write here -1, okay? Yeah, so then now we can now replace. So put everything in the formula accordingly. So we have the dy dx is given by f prime, and f prime we have gotten the answer to be 12 into 3x minus 5 power 3, and then times g of x, which is 7 minus x power 10, plus g prime of x. Now, I hope you can see that this will be minus 10 times this bracket power 9. For the g prime of x, 10 times -1 is just -10. -10 times -1 is just -10, okay? So I can write this one as -10 into 7 minus x power 9. Then times the f of x net part here, 3x minus 5 power 4. Okay. So what I can do here, am I not using? Good. So then now, let's see. Here we can do further factorization. Na tuanze na hizi hapa. Hii number hapa ni 12 na hii hapa ni -10, okay? What is the common GCD of 12 and 10, or 12 and -10? Largest number that can divide 12 and 10? 2, okay? So tunaandika 2 into then hii hapa yenye iko na 3x minus 5, hii ya kwanza iko to power 3, okay? Alafu ingine iko to power 4. So which means that the GCD ni yenye iko ndogo power 3, okay? So naandika hapo power 3, okay? Haya, twende kwa hii ya 7 minus x. Tutachukua gani? Power 9 ama power 10? Power 9. So 7 minus x power 9, okay? So what should I multiply by 2 to get 12? 2 to get 12. 6, okay? Sasa hii 3x minus 5 power 3 iko hapa. So hii inaenda cancel out, like cancel out, okay? And then hii ingine hapa inabaki, hapa ilikuwa 10 na hapa tumechukua 9. So inamaanisha inabaki just moja. Okay? And then minus 5 plus minus, I hope you know there's minus. And then into sasa 7 minus x hiyo power 9 imeenda juu tumeshaiweka nje, si ndio? And then hapa inabaki 3x minus 5. Juu tatu ziko nje, okay? Yeah. So then now you can say this will give us 2 into 3x minus 5 power 3, 7 minus x power 9 into, this is 6 times 7 is 42. Okay? And then six times minus x minus x. Minus x, yes. Correct. Minus 5 times 3x. And then minus 5 times minus 5. Plus 25, correct. Okay? So this will give us 2 into 3x minus 5 power 3 into 7 minus x power 9. Those are 40, let's collect like terms, 42 plus 25. 25. 67, correct. So tunapata hapa 67. Then minus 6x minus 15x. Minus 15x. Minus 21. X, okay? Now that become the final answer. So this is the final solution. So I gave you 1 minute to copy. Or are you done with copying? Okay, good. So let's go now to the problem number 3. The other problem was to find the y dx given that y is 4th root of x plus 3 divided by x minus 2. Okay? Now, 4th root means raised power. Over 4, yes. So unasema this problem simply means this implies that y is x plus 3 over x minus 2 raised to power 1 over 4. Okay? Oh. So dy dx. Remember, if you should be able to see that all the what is inside, all of it can be fixed to be u. Okay? So tukitumia chain rule, the dy du will be given by let's just write. So dy dx is the same as dy du times du dx, okay? Where we let our u to be that bracket, x plus 3 over x minus 2. Okay? So kama this is u, then inamaanisha y inakupatia u power 1 over 4. Okay? dy du y minus. So when you drop, how does it become minus? If you drop 1 over 4, how does it become negative? So inakupatia ngapi? 1 over 4 u power and then juu sasa tuna drop the power, then tunatoa 1 from the power, okay? Yeah, so minus 3 over 4. So i.e. this just be 1 over 4 into x plus 3 over x minus 2 power minus 3 over 4. Okay? Sasa to get du dx, tunatumia which formula? So remember, this is our u. This is what is given by u. Which rule do we use to get the derivative of that? Quotient, because it comes out, the function comes out like a fraction, okay? Yeah, so quotient tunasema we have f prime times g of x minus g prime of f of x divided by squared. Correct. Okay. Yeah. Sasa ukitafuta G prime, so remember ya juu ndio unaita G, ya juu ndio unaita F, then ya chini unaita G. Okay? This is usually the F, this is usually the G function. Okay? So inamaanisha the F prime itatupatia ngapi? Ukidifferentiate x plus 3 unapata nini? Hmm? Hata mimi sijui. Mimi sijui, mimi chenye naona tu ni x plus 3. That's what you want to get the derivative. Which constant? Inabaki hivyo. Eh. Hizi baki hivyo. Inakuwaje? Mm. Mm. Haya, utapata ngapi? Mm. Mm. Sasa jibu ni nini finally? F prime. 4. Angalia, tumesema aje? In the previous question we said that derivative of a constant is always 0. Usisahau hiyo, that derivative of a constant is always 0. Please don't forget that. Derivative of a constant is 0. Okay? Sasa hiyo usisahau. Sasa tunataka kutafuta derivative ya x plus 3. Term by term. Ukidifferentiate x unapata nini? Ukidifferentiate x unapata nini? 1. Ukidifferentiate 3 unapata nini? 3. Unapata nini? 0. Sasa what is 1 plus 0? 1. Sasa jibu inakuwa f prime inakuwa 1. Sawa? Haya, sasa times g of x ambayo ni x minus 2. Sawa? Then g prime. So differentiate x minus 2 na niambie jibu nini? Zero. Mm. Itakuwa nini? Minus 1 umetoa wapi? Minus 1 imetoka kwa minus 2 aje? Okay, x inatupatia. Sasa let's go term by term. X inakupatia ngapi? 1. Minus 2 inakupatia ngapi? Sasa 1 minus 0 inakupatia minus 1. Inakupatia ngapi? 0. Yeah, sasa hapo inabaki 1 bado. Sawa? Good. Then times f of x, which is x plus 3. Then g of x squared. Hapo chini ni x minus 2. Then we square it. Okay? Yeah. Sasa tuna simplify this. 1 times x. 1 times minus 2. Minus 2. Minus 1 times x. Minus x. Minus 1 times 3. Minus 3. I'm happy that now you are very careful with signs. So that should be encouraged. So the way you are very careful with signs now, I want you to be very careful with the derivative of constants. Okay? When you see a constant derivative, then you know the answer is 0, okay? Yeah. So then now, hapa x na minus x na cancel out, eh? So minus 2 minus 3. Minus 3. Minus 5, sindio? Sasa hii ndio inatupatia du dx. Sawa? Na usahau hapa tuko na dy du. Okay? So then I think now the remaining task is much easier. The derivative we know is the dy du times du dx, okay? So therefore, yeah, dy dx is dy du times du dx. So dy du tumepata ni 1/4 into x plus 3 over x minus 2 raised power minus 3/4. We multiply by minus 5 over x minus 2 square. Okay? So that's what we get as our final answer. Ask. Time du dx. Times du dx, yes, because we are using chain rule. Yeah. So that's always the case. Whenever now you now bring in the aspect of fixing one part to be u, then this will always be the formula that dy dx is the same as dy du times du dx. So this is now the simplest part. This is the simplest part of the problem. Or if you want to complicate it, then you can as well put now this you see this x plus 3, you raise it to minus 3/4. Na hii chini pia x minus 2, you raised for minus 3/4. Then hapa ni minus 5 over x minus 2 power 2. Then hapa ni 1/4. I don't want to do this to go to this one because I get confused for no reason. Yet the when you stop at this point, still the same. But you can still play with the indices, these laws of indices, and then put this and this together. But we don't have to go those examples. Yeah, that's the final answer. Yes. So now I want us now to go to higher derivatives. Okay. Yeah. So higher derivatives. So that once you understand how to get this, how to play with the power rule, how to play with the quotient rule, this product rule, and chain rule, then higher derivatives is just an easy thing because it means repeating the same process more than one time. maybe twice, thrice, fourth, depending on what you want to define. So higher derivatives. Okay, no problem. I can share after this, I can scan and then share, then no problem. So what I want you to master, there are key things so that now then writing, I can always scan and then share to the class. Yeah, I just want you to note down the key things in the problem so that now when we are solving a problem, you're able to follow through. Okay. Yeah. So we write f prime of x, which is the same as dy dx, which is the same as y prime, which is the same as you can write df dx, to mean the first, or simply the derivative of the function y equals to f of x. So if we differentiate the first derivative we get the second derivative. I.e., d dx of f prime of x is equals to f double prime of x. Similarly, when you write d dx of dy dx, then you get d squared y dx squared. Similarly, when you say d dx of y prime, you get y double prime. And when you write d dx of df dx, you get d squared f dx squared. Oh. Yeah. And then similarly, to get the third derivative, we differentiate which derivative? We differentiate the second derivative. So this to mean that if I find d dx of f double prime of x, we get f triple prime of x. Then d dx of d squared dx squared, I write it as d cubed y dx cubed. And then when you differentiate y double prime, you get y triple prime, etc. And this game continues up to what we call the nth derivative. Okay? So inamaanisha tu to get second derivative, una differentiate the first derivative. To get the third derivative, you differentiate the second derivative. To get the third derivative, you differentiate the second derivative, okay? To get fourth derivative, you differentiate which derivative? To get fourth derivative? Third derivative. Now to get the 10th derivative, differentiate the 9th derivative, okay? Yeah, so differentiate the 9th derivative. Now these things are orderly in such a way that ukianguka first derivative, then all other derivatives will be wrong. Because you move from one step to another step, then to another step. So if you mess up with one, then other higher derivatives will be wrong. Okay. So you ensure that you do the correct derivative when you're starting so that you don't mess up the process. So for example, let y be given by x power 4 plus 2x power 3 plus x squared plus 10. Okay. So first derivative, what we call dy dx. Tell me, what will be the dy dx of this function? Don't forget what we have done previously. They are the same things are being applied. The power rule, the product rule, the quotient rule, all those other things. So you don't leave them. As you move along, as you go forward, you must always remember them because they'll still be applied. Four x power 3 plus how are you getting 2x power 2? Okay, so if someone gives you this, if y is given by a x power n, what is dy dx? I have the function y equals to a x power n. I want you to tell me what is dy dx. Huh? Why are you getting D? I said this is small a. Ah, mm. Into x. Ah. Hey, you want to scare people. You are complicating the obvious. So maybe wachana na hii. So y equals to x power n. What is the y dx? Dx nakupatia ngapi? xn. How did we define power rule? Hmm. So then tell me, what is dy dx of this function? Okay. Not xn, nx raised to n minus 1, okay? And then this alone will be this one now. What I asked initially, if I have a x power n, what is dy dx? Nx. So n x power negative 1. Just try to apply the same thing that you have done to this other problem. It's exactly the same thing. Stick to the same rules we have used to get this answer here, and you should be able to tell me the dy dx. Apply exactly the same rules. What you have done to this to get this, apply it to this same problem. What? Mm. Mm. What will be the final answer? What is the final answer? Why can't you just do the same thing you have done to this? That when you are given the x power n, you are starting by drop the n and then subtract 1 from the n. So here you have subtracted, but you have not dropped the n. So it just is incomplete. This is incomplete. Don't complicate your life. This what is happening. The power rule, you drop the power, then the new power becomes the original power less 1. So when you drop this n, are you not just going to have n a, and then the new power will be n minus 1? Also just dropping it, just the same way you did to this other thing. You drop it, then you write it before x, and then you subtract 1 from the original power. So then now tell me, what will be the value of dy dx for 2x power 3? Okay, when you write NA, what do you mean? What is the operation between A and N? If I write NA, do I mean N plus A or N times A? So then now you can't get 5. Six, and then X power 2. Then next, you are still making the same mistake. Derivative of a constant, I still remind you, of a constant is 0. Okay, so then now, so that's what you call a first derivative. Then second derivative. So second derivative means you differentiate the first derivative. So it's written as d squared y dx squared. So means you differentiate, this is d dx of the first derivative dy dx. So when I differentiate 4x power 3, I get (12x power 2), and then plus hmm, 12x, and then plus 2x. Plus what value? Plus 2 or 2x. Yes, 2, correct. Then third derivative means we differentiate the second derivative. So d cubed y dx cubed is d dx of the second derivative. So when you differentiate 12x squared, you get 24x, and then next 12 plus. So we don't have to write that 0, okay? Then fourth derivative means you differentiate the third derivative. So remember, when you get any of any of them wrong, then all the things that follows will be wrong answers. So you have always to be very careful, okay? Yeah. So when you differentiate 24x, then 12, just 24, okay? So fifth derivative means you differentiate the fourth derivative. So d5y dx5. So differentiating 24. We are differentiating 24. That's the answer to the fourth derivative. So when you differentiate, what do you get? 0, because they're constant, okay? And then I should now say that the fifth derivative will be the same as the sixth derivative, will be the same as up to the nth derivative, etc. All of them will be 0, okay? Because we're just differentiating 0 every time, or differentiating constant. So that is how we evaluate the higher derivatives. So then now I want you now to tell me if I have this as my y, this is now your time to suffer. I was the one who was suffering now. This is your time. So, so then given y equals to x power 5 minus 3x power 4 plus x, I want you to find y prime, which means the first derivative. We'll get five x minus 12x power 3 plus 0. You are sure with that answer? I want you to mark yourself. Do you trust that answer? Sure. Okay, let me now mark for you. So this is wrong. This is right. This is wrong. Are you going to redeem yourself? So what is the correct answer to the first part? What is the first answer to the first part? That's what we match up before. Plus 1. So now imagine if this question was given to you and you do this one, you will mess up with all other steps. So then be careful. Huh? Yeah, so be careful so that now you get the right thing. Then second derivative. Then minus that 6 x raised to power 2. And then plus 0. So we don't have to write that 0, okay? Then that derivative. It's 60x x power 2 minus 72 x. Okay. Then fourth derivative. $120 x minus 72. And then fifth derivative, $120. Sixth derivative, zero. And then this follows that the rest of the derivatives will still be zero. Yeah. All the way up to the nth derivative. All this will be zero. Okay. Good. Then the other one, here is another problem. Now, this one, you have to ensure that you get everything right for me to give you space. Without getting this one right, we're not going to take up. So, okay, so y is equals to 4x power 2 plus 3x plus 4. So what is y prime? X plus plus 3 then second derivative h, and then third derivative 0. Okay, good. Lastly, y is 1 over x. So I want you to find y prime, y double prime, and y triple prime. So what would be the y prime? Kolbe? By the way, 1 over x means x power. It will be x power half if is square root of x. So this is just x power minus 1, okay? So remember, 1 over a power n is the same as a power minus n, okay? So remember that rule of law of indices. So this will give us, now tell me now, what will be the y prime after helping you to convert? Forget? We're just still applying power rule, so don't complicate it. We are still using power rule, don't complicate the problem. Minus x. Nani anza? What did we say? If y is x power n, dy dx is? Hmm? Power? Power y? Ah, power 1. Nx? This is the formula. We have done it here. You are the one who gave this. So then now tell me the right answer. Hmm. So then now tell me what is the answer to my question now. dy dx of x minus 1. You get? Just apply the same thing we have done here. You know what is your n, so just replace into the formula and tell me the simple equation. Where n now, for this case, n will be -1. So where is n, put -1 in the formula and tell me the simplified expression. Yes, that's the power. That's the power we have in this question. Mm. So just replace minus n in the formula, put -1. Let's see. So this will be minus x raised power -2. So because we are going to have -1, -1. Okay. Now tell me the second derivative. So when you drop the -2 times -1, you get 2. What will be the new power of x? What will be the new power of x? Remember, the n is -2. And the formula is n minus 1. So what is -2 minus 1? -3. So tell me now, what will be the value of the third derivative? -6 x power -4, not -2. Remember, n is -3. So -3 minus 1. Okay? So now tell me, what is the fourth derivative? Mm. -24 x power x power -5. Okay. Hello. Naenda. Correct. Ah, mapema. Alright, kama niifanyie nyumbani. Sawa sawa. So then I work on this. Hello. I want you to try this. Find y prime and y double prime given y is x squared plus 10x raised power 20. Okay. This is the homework I'm giving you. This is just one problem is enough. Okay.